real transformer. Come, let me show you the real one. We have no time to finish our project already. Let's go finish.
Let's go.
Hi guys, we are group 3. My name is Kaishan and I'm here with
Shane, Kakao.
Puja, Christine.
and today we are going to talk about
Transformers.
Hello everybody, how are you guys doing? I'm sure the reason you clicked on this video is to know everything about a transformer, so let's get to it. Firstly, what is a transformer? Well, a transformer is a static electrical device that transfers electrical energy between two or more circuits. A varying current in one coil of the transformer produces a varying magnetic flux, which in turn induces a varying electromotive force across a second coil wound around the same core. Electrical energy can be transferred between the two coils without a metallic connection between the two circuits. Faraday's law of induction, discovered in 1831, described the induced voltage effect in any coil due to changing magnetic flux encircled by the coil. Transformers are used for increasing or decreasing the alternative voltages in electric power applications and for coupling the stages of signal processing circuits.
Hi guys, I'm Chanka Hao, and today I'm going to show you how to do a setup for a transformer. First, we'll need an AC power supply, and we'll need an oscilloscope, and then of course we need transformer and also wire with crocodile clips. First, we have our oscilloscope plugged in and turn on the electricity and our power supply too. Then I'll show you the original voltage. It's like this, which is 2 on the y-axis and negative 2 on the y-axis. Then when we put our wire to the transformer, which is step-up transformer, we have to connect our oscilloscope to the other end. And when the AC power supply is turned on, the magnitude of the voltage is increased.
Hi, I'm Puja, and today I will be explaining the principle of operation of a transformer. In this image, we have a step-up transformer. In a step-up transformer, the primary coil has less number of turns than the secondary coil. In both step-up and step-down transformers, a soft iron core is used. This is because it is easily magnetized and demagnetized. An AC power supply is attached to the primary coil, while the secondary coil is attached to a resistor, such as a TV or a laptop. An AC current is used as it changes direction every half cycle, resulting in an alternating flux. When this flux is cut by coils, an EMF is induced in the secondary coil. A DC current supply is not used as the DC current flows in only one direction, and this doesn't create a change in magnetic flux. As a result, an EMF is unable to be induced.
Hey guys, I'm Chanka Hao, and for now I'm going to talk about back EMF. So what is back EMF? Back EMF, as the name suggested, it is a backward EMF that will flow in the opposite direction of the voltage applied. For example, back EMF. Here we have a coil where we apply voltage from the top of the coil. The voltage applied will move in a downward direction. And the back EMF will move in the opposite direction of the voltage applied, which in this case will be the upward direction. Back EMF in transformer. So how did it occur? It occurred when AC voltage is supplied to the primary coil of the transformer. Therefore, there will be change of magnetic flux. When there is change of magnetic flux, there will be induced EMF at the primary coil also. and the direction of this induced EMF will oppose the direction of voltage supplied to the primary coil.
Now, I'll be introducing to you energy issues in a transformer. First of all, what we have to know is that in ideal conditions, when the secondary coil is not connected properly, all the input electrical energy will be used to produce back EMF in the primary coil. Hence, no energy is transferred to the secondary coil. When the secondary coil is connected, all the input energy is transferred to the secondary coil, and there will not be any energy loss in the form of heat in the windings or the core. With this, we have a formula, which is primary current times primary voltage equals to secondary current times secondary voltage. We cross multiply it to have this, which results in this equation, which is primary current divided by secondary current equals to secondary voltage divided by primary voltage, also equals to number of coils in the secondary system divided by the number of coils in the primary system. However, in real life conditions, there is energy loss. There are 4 types of energy issues in a transformer, which includes resistance of wires, flux leakage, eddy current loss, and hysteresis loss. First of all, we have resistance of windings. A low resistance copper wire is used for the windings. Although it is low resistance, there is still resistance in it, thereby contributing to heat loss. Next, we have flux leakage. Flux that is produced by the primary core might not all be linked to the secondary core if the design of the core is bad. This results in energy loss. Other than that, we have eddy current loss. The changing magnetic field not only induces currents in the secondary coil but also currents in the iron core itself. These currents are called eddy currents, which causes heat loss. Lastly, we have hysteresis loss. The magnetization of the core is repeatedly reversed by the alternating magnetic field. The repeating core magnetization process expands energy, and this results in loss of energy in the form of heat.
Now I would like to talk about the solutions to the energy issues in the transformer. The solution to resistive loss in windings is to use thicker wire to reduce resistance. As we all know, R is inversely proportional to the area of cross-section of wire. Another way is to increase the voltage so that the current is low. The solution to magnetic flux leakage is to reduce the magnetizing current to the minimum by using soft iron core, or placing both the primary coils and secondary coils closer to each other to reduce the leakage of magnetic flux. The solution to eddy currents is to laminate the cores using silicon steel. The solution to hysteresis loss is to use silicon steel or high-grade steel, or use the material which has the least hysteresis loop area.
Application of transformer in power transmission. As electricity continues to be an integral part of many people's daily life, transformers have evolved to take up an important role in the generation and distribution of electrical power. Transformers regulate electricity by modifying current to run from one electric circuit to another. Each electric circuit has a certain amount of windings that are present around an iron core. The number of windings either to increase or decrease the incoming electric voltage. One of the applications of transformer in power transmission is to regulate the alternating current. It's well known that all transformers have one basic function, which is to increase or decrease alternating current within the electrical system. By regulating the flow of current, the transformer allows the increased energy efficiency, which helps to reduce the electricity bills and the costs. Here is given by one formula of the efficiency of transformer is given by output power over input power times 100%. Transformers are used in battery charging devices. Step-down transformer can be found in all electronic devices that can be run from domestic 240-volt AC supply. High voltage from the electrical cables need to be lowered down to 240 volt, as most of the households requires low voltage to enable the functioning of electrical devices, such as oven, microwave, television, and so on. If there's a child asks you, where can I find a transformer in real life? You can tell them, iPad, phones that you are using, they are all transformers. Transformers are used to control the voltage that enters the battery during the charging process in order to prevent any damage that can occur to the internal battery components. This is important because an unregulated voltage can result in high surge during charging of batteries. Besides, to manufacture steel, high voltage transformers are needed to provide range of voltage for manufacturing process. High currents are required during melting and welding of steel. However, lower current are required during the cooling process. So in order to provide this range of voltage, transformers are necessary for regulating currents within the system. In addition, transformers are used in electrochemicals process. In chemical engineering and manufacturing process, electrolysis is normally fueled by functioning of transformers. Metals such as copper, zinc, and aluminum are normally used for the purpose of electroplating. During the process, transformers provide a regulated electrical current that is used to drive the chemical reaction from the beginning stage until the completion. The current can therefore be regulated as the reaction proceeds. Here are some formulas related to the transformer. One of the most obvious applications of transformer is in power transmission. Based on formula P equals I squared R, the power consumed by a circuit element is proportional to the square of current flowing through it. In order to reduce power loss in transmission line, it is desirable to transmit the least amount of current possible. For a fixed amount of power, the best way to decrease the current is to increase the voltage. Furthermore, it is possible to use a transformer to make the load appear larger or smaller so that the load receives maximum power. However, the maximum power is not equal to the maximum efficiency. For maximum efficiency to be produced in the use of electrical energy, the load should have extreme resistance so that the energy loss will be negligible. Looking into equations, extreme resistance will receive low amount of power. For any constant given voltage across any load, the power received by the load is given by P equals V squared over R. Thus, the relationship of power is directly proportional to the square of voltage and inversely proportional to the resistance. But please note that this equation is transformed with Ohm's law. It changes with Ohm's law and is only appropriate since current will drop in this case if resistance increases. How do we improve the efficiency of a transformer? First of all, we can use a better grade of core material. A better grade of core material has lower hysteresis and less eddy current is produced. Secondly, we can use soft iron core. A soft iron core is easily magnetized and demagnetized easily by the magnetic field of a solenoid. Soft iron core can be used to reduce the energy needed to bring about the magnetic reversal in the coil. Soft iron core is able to concentrate magnetic field lines and thus a stronger magnetic field is produced and resulting in more change in magnetic flux. To improve the efficiency of a transformer, a thicker copper wire must be used. Larger diameter of the copper wire reduces the resistance of the coil. Energy is lost as heat energy, and the power loss equation is given by P equals I squared R. As the resistance of the coil decreases, power loss decreases accordingly. Furthermore, iron core should be a closed loop of iron with a secondary coil wound over the primary coil, or you either place the secondary coil very close to the primary coil. This is because electrical energy is lost when the fraction of magnetic flux produced by the primary coil does not cut the secondary coil, and this resulting reduction in EMF induced in secondary coil. Moreover, use of laminated soft iron core. Laminated soft iron core reduce eddy current, which in turn reduce the heat in the core, and hence the energy loss is reduced. Lastly, we must keep the transformer as cool as possible to improve the efficiency of a transformer. This is because copper resistance increases with temperature and their relationship is directly proportional to each other.
So in this video, we'll talk about the setup of transformer, the principle of operation of transformer, the energy issues in transformer as well as the methods to overcome them, and the applications of transformer in daily life. So now you have understand what a real transformer is. Thank you for watching.